Just cut out the first minute, it's fine. Hi, I'm Tom and I talk about code. Welcome to another Rust programming live stream where today I'm going to be building more of my simple virtual machine that I started last time. Last time we got something that could run simple instructions. We were manually poking a program into memory. Let's take a look at where we left off. Cargo run. We were adding numbers together, and if we have a look, we were writing the program push 10, push 8, add numbers on the stack, and then pop the top of the stack into a register A, and then we're just manually inspecting this register, right? So adding 10 and 8, we get 18. If we come in and change these magic numbers, let's say 10 and 10, we should expect to see 20. Beautiful. And this is the basis of the computer, right? We could finish here and say, yeah, cool, you know, some crazy isomorphism about addition and stacks, and maybe there's computation you can do. Like we could probably add just a few things, but we're gonna make this a much more interesting computer, and we're gonna start by making it easier to write and load programs. So let's start not here. Let's start by writing a new binary that's going to use the same bits, the same parts from our kind of core simple VM library. And we're going to call this ASM. We're going to go into our cargo.toml and we're going to create a new binary. Right, so this basically just says, hey, look at source/bin/asm.rs or source/bin/asm/main.rs, I think. You know, it just tells Cargo that we have another binary, and that's why we've gone for this kind of setup where we're primarily building a library, but then we're building binaries on top of it, because we want our assembler and our VM and any other tools we build to all share a little bit of code. So that's going to be good. That's going to be good. Okay. So, assembler. But when I say assembler, we're actually going to write something really silly. Okay, our assembler, our spec for now is going to be open a file. Now, I made some notes off screen about opening files, okay? Because, well, I've not done a lot of Rust. I didn't really know how this would work, so let me just sneakily refer to my notes. Where is it? Beautiful. Okay, so, for one thing, we can get arguments, right? So the way this is going to work, we're going to have, let's say, asm file.asm, and then this is just going to print to standard out. Nothing too crazy. So one argument. We expect one argument for this binary, and we can say let args. We can collect all of the arguments passed into this by this fantastic one-liner, right? So where we get the args as some kind of like iterator, I guess. We collect them into a vector, and then we can do things like examine their length. I think I want stdenv. I'm pretty sure that's what I want to include, but we'll find out when I try and run it or build it, because Cargo gives very good error messages, as we've learned. Let me just make sure I can actually see my chat as well. Isn't that nice? Isn't that lovely? Okay, cool. So now, well, hold on. We want to make sure that the length, so if we don't have 2 arguments, then this is just going to be a panic. We could do better errors eventually, but for now we're just going to panic. Usage args. Actually, is that okay? This is something we've got to search. Rust panic and format. Right? Is this 2 things? Does it take? It does. It takes a format specifier. Okay. So this is a fun little thing. If you haven't seen this before, we're going to use args0 as our kind of token here, because that means that whatever name we've used to run the program is what appears in the usage. Nice little thing. This will also blow up if there's no args0, but if there's no args0, then we're running in some kind of weird, like, non-standard environment. We don't really care about that. Cool. So let's grab the actual source file into a thing. Sorry, you'll have to excuse me. I may periodically have to wipe or blow my nose. God, I've been very unwell this week. I'm feeling okay today, but just not quite there yet. Still a bit sniffly. Cool. So let's say input file name, I guess. We're going to grab out of args, and I think I want to borrow this. I'll leave it without the borrow, even though I think we need to have a borrow there, but we'll let Cargo tell us what's wrong when we try and build. Cool. Now, we want to open a file. there is a method file open, or a function rather, file open that we can call. We have to convert this file name string into a path, which is kind of fun. I don't really know why. This doesn't really need to be a variable, does it? That's okay. Now, this is going to return, what does this return? Some kind of result, maybe? Yeah, it's some kind of result. So let's match on it. And then we're going to say error. Failed to open file, and just dump out whatever this thing is here, which apparently is convertible to a string, which is cool. And then if we get a file, well, we get back a file, and then we can do things with that file. One of the cool things with Rust is all of these statements are actually expressions, so we can return something out of it and assign from it. And I think this is okay. Like, we're returning something in one branch of this and we're panicking the other, but I think Rust works out that this is okay, even though these technically have different return types. Cool. Okay, so we've got a file. Now what we're going to do for each line in file, for each space separated token, try to parse as base 16 number. So for every line, for every space separated token, this is another indentation, we're going to see if it's a base 16 number. So basically we're going to have an input file that looks like this, right? 00, 01, 02, 03, 04, 05, 10, right? And this is just going to be, output is just going to be these bytes. That's it. We're not doing anything fancy. We're not doing anything crazy. That's all we're going to do for this first pass. And this is going to let us write programs that look a lot like this, but we're not going to write them in the actual source file. We're going to write them in independent files, assemble them into little dumb binaries. And there is some Linux one-liner that could do this, but we're going to write a Rust binary first and then start tweaking it a little bit. It would be cool to actually keep the ability to just have inline arbitrary binary nonsense eventually. But anyway, let's just write this in Rust because I want to familiarize myself with opening files, reading lines from files. I just want to experiment with this a little bit first. So immediately, this is the end of my script. I don't know where I'm going from here. So let's see if there is a Rust by example read lines. This sounds like exactly what we want. Read lines. Damon in the chat says panic returns the exclamation mark type, which tells the compiler the program terminates before returning, so it satisfies the type checker. Perfect. That's kind of what I thought. I thought for some reason it was like well, I guess it's like a special kind of unit, right? But it's like something that means something else to the compiler. That's cool. That's really good to know. Okay. So it looks like we can wrap this file in some kind of buffered reader, and that just has a lines method. So that looks like what I want. That very much looks like what I want. So let's say IO buff reader. What is this? IO buff reader new file lines. For now, do we want to enumerate, or do we just want the line? So for each line, we're gonna split this line in by space. Then we're gonna filter, because we want to get rid of anything that's empty, right? Because the way Rust's split works, it's gonna, if we have like a lot of spaces, if we have like extra spaces here, there'll be garbage empty strings in the middle. So filter not x.empty or .len equals 0, I think, right? So if the length, if the length is greater than 0, filter out if the length is equal to 0. Yes, cool. Okay, so for s in, so for each, let's call it t for token, right? We need to try and parse it now. Rust parse u8 hex. convert UTF hex value to char in Rust, maybe? Hex string, U8 to hex string. This is the opposite of what I want. I want hex string to U8. Parse. Hex U8. This is, again, kind of right. U8? Not quite what I want, U8. Parse. Oh, hold on. Oh, that looked right. From stir. What was that called? From stir radix. Damon was doing something similar. He needed to parse a CSV. What were you parsing CSVs for in Rust? It does sound cool though, right? Like, you know, you get some nice little one-liners to clean up your data. Okay, this is literally what I want. Now, what am I saying here? U8 from stir radix. We're gonna have our token. It's gonna be base 16, and we're gonna say map error, maybe, because we want to turn this error into something that main will understand. And then we can actually just come back here. We don't even need to match anymore, do we? We can do the same thing. Right, rather than manually matching, we can use this nice bit of syntax shorthand to do it for us. Cool, and same thing here, X. We're just gonna say format. Let's look at what is actually in a parseInt error. Two-string. It has a two-string. Cool. So we get this number like as a byte. We assume that it is going to be parsable as some kind of hex digits. So in this case, you know, 1, 2, 3, 4, 5, 16. Damon built a neural network and was doing experiments on stock data. That sounds very cool. That sounds a little bit like the kind of thing my brother works on, but without he does it without the neural networks, I think. I'm not really sure. But yeah, you need some good high performance code there. Alright, so we've got a byte. Now we need to put it in some kind of output. And let's do the dumb thing for now. Let's say output, make the output, which is going to be a vec of U8, and we're just going to make a new empty vector. Oh wait, no, hold on. Vec new, that's the better way of doing that. Don't do anything fancy, and let's just say output dot push b. I think we push in Rust. I don't think we append. I don't think we push back. I think we just push. Cool. Now we need to write Rust write vec u8 to just write it to standard out. Cool. Standard out. Can we just grab standard out from somewhere? It looks like we can. Okay, so let mute standard out equal IO standard out. Looks like we can lock it. That sounds like a good idea. I don't know what this does, but it sounds like a good idea, right? I don't want anyone else using my standard out. Let's lock it. Let's keep control of it. Cool. Standard out dot good question. What is this? Right. This is good. Okay, write all. Can we pass a vec to this? Right? If we borrow a vec, does this fit? Let's find out. Let's find out. Excellent. Okay. Let's find out. Well, obviously what's going to happen here is things are going to go badly. we're going to have some things that we haven't done properly. We need to import buff reader, and I guess maybe that's it. Maybe that's it. Let's find out what happens. So now when we go cargo run, it can't decide what it actually wants to run. We need to tell it which binary we're trying to run, because we have two binaries now. Okay, so maybe I need to import stdio on its own, and then also the one with the subpath, right? Because we want two things. Okay, this is good. This is good. It's telling us nice things. It's telling us that, first off, somehow this buff reader is not used. It's also telling us that we need to import a trait if we want to use this implementation for some reason. I don't really understand what this is, but we know how to read an error message, so we know what to do. Okay, now we expect this to blow up eventually anyway, right? Separator must be a double colon. That makes sense. 9. File. This is also good. I'm pretty sure this is in stdio as well. So that's good. That's good. Line 9. We need this double separator. It looks like stdn was the correct guess. We love this. We love this. No file in IO. Okay. Doesn't have a helpful hint, but it can tell me that it's wrong. It can, however, tell me that this one is what I want. So that's good. So I want use std path. Lovely. Where does file live? Where does file live? It is use std fs file. This was in my pre-show notes. Oh, Damon says they would do all of this inside of an iterator using maps and call collect at the end to collect everything into a vector. So instead of having this, building a vector and appending, they would do something smarter here. The thing I always struggle with that, right? Like, if I was just turning each line into one byte, that's fine. But because there are, like, I would have to build a vec, I would have to collect this into a vec, and then collect, or like, what's that called? Where you fold, right? Fold and concatenate, I think. And that would maybe be more idiomatic. That might be more idiomatic. Like, map each line into a vec that's collected from this. Flatten. Okay, apparently in Rust, this is a flatten. My Haskell is letting me down. I forgot what I was doing. I think this is good. I'll get this working like this first, and I'll play with that. I'll try and be a bit more idiomatic. That does sound good. Buff reader is unused. Oh, because I'm namespacing it anyway. Well, that's cool. I don't need to be explicit about it. Well, actually, I can just say this instead. I don't care. Lines, okay. Lines not found in buff reader. Ah, well, it's part of a trait that I haven't imported, so I do need, while I have imported buff reader, I also need to import buff read, which will make that trait available. Excellent. This is a very subtle thing in Rust, and it's kind of hard to understand. I've also still got this dud import that I need, well, I got rid of, but I need to get rid of again. Okay, the method split exists for enum. Oh. God. Sorry, I'm still a bit gross. The method split exists for enum result. Trait bounds were not satisfied. Method cannot be called on result string error. So does this mean that the line, like we're not unpacking something that we should somehow? Lines does not return what I think it does. Rust buff read lines. We've got to look at the docs. Lines, what do you say? It'll just be that this returns a lines. Okay. Lines is wrapped in an option. In my chat, we've got lines is wrapped in an option, but is it? Lines. Like, it looks like it isn't. Unless somehow the iterator The iterator makes each item a result string error? I don't understand this. I guess so it's not the line. Yeah, so each line is wrapped in a that's weird. I'm confused by this. But anyway. So we can just do this, right? And it's very silly. Temper Theta Delta, welcome. They're very excited to be catching a stream live. Which I always love to see. Ooh, and argon? Argon? Is that a Q or is that a G? Also excited. Yeah, I'm streaming at a different time to usual. I should try and do streams at this time of day. More people seem to stop by. More people in other time zones seem to like it. It's either very early morning for me or more in the evening. You could probably not guess it from my window, but it's getting kind of late here. It's like, I don't know, it's like 7:30, 7:40 or something. I'm getting a little desperate here, but I just want to see something run. Cannot borrow as mutable. We haven't made our vector mutable. So again, like, this is another thing for using map and flatten instead of building a vector. We wouldn't need to have something that's mutable. All right. This is a result as well. But format IR, a map error. This is a really silly use of format. Okay, there we go. Excellent. Compile and run. Finish running. Panicked. Because we didn't pass it an input file. Excellent, excellent. The iterator return from this function will yield instances, yeah. Archon enjoys the PS2 dev videos. Thank you very much. Thank you very much. Yeah, okay, the iterator, why does the iterator return a result? That's, like, it makes sense, right? Like, you're reading something in a buffered sense, the next read could fail, but man, that's, yeah, it feels a bit janky. I guess it's the correct place to represent the uncertainty. Cool, so let's write a file. What did I just say? Test ASM. Okay. And let's port whatever we had in our virtual machine. So we're gonna have one. We're gonna write all of these as double, like double digit. Except this isn't. This is hex, so this is A, 01, A, 01, 08, and then it's 03, 00, 02, 00, 03, 00, 02, 00. Because we just didn't write the O because it was missing. That's like, it's this op just takes no arguments. Returning. Oh yeah, okay. So yeah, returning a result. Like, what would happen if you hit end of file? That also makes sense. I don't know. It's interesting, right? I feel like that should just be the end of the iterator. Like, you wouldn't need to communicate it, you just wouldn't have any more lines, that the iterator just ends. It seems to make more sense, yeah, but if you're expecting a string to be like valid UTF-8 characters, it could fail like whatever the UTF-8 character is. I guess imagine it's a network as well, and like there's a network error. Okay, cool. There's another thing we need to do here so that this doesn't blow up, maybe? Or maybe not, actually. Okay, let's see what happens when we run this. Cargo run, and our input is going to be test.asm. Cannot pass integer from empty string. Okay. We've done something wrong, and I have a few theories about what it is. Filter. What does the filter function actually do? filter. No? Do you have... No? Okay, oh. Because this is like returned by something. Created by the filter method. Okay, filter predicate. Return yield only the elements for which the closure returns true. I wrote this backwards. I want the length to be greater than 0. Excellent. And we get nothing. That's okay. That is okay. Okay, so what does this mean? This means we need to dump the output into something. Oh, excellent. That's actually exactly right. 01, OA, 01, 08, 03, 00, 02, 00. Perfect. That's a program. Let's call it something better. Let's call it prog.bin. Cool. So, now if we go into our virtual machine, we need to do something similar to load a program. Let's just get rid of all these lines. So we're going to copy whatever we did before. Let's just quickly split the screen and pull up the other file. And this is going to be a little ugly because my font size makes this a little awkward. That's okay. It's okay. Cool. Okay. So we're going to have to copy a bit of code here, but we're going to collect args. Actually, I can probably just copy and paste. It's not what I wanted. Cool. This is all good. Now, we just want to read the entire thing into like a vector, right? So let's see what buff reader has in it. Let's see what it has. What methods have we got? I just want to read it all. Just want to read everything. Buff read. Fill buff consume. Has data left. Read until, read line. I just want read. I want read everything. Read to a specified buffer. That's okay. Read exact. Read vectored. Read to end. Here we go. Technically the iterator returns an option result string. Let me pop this out so I can actually look at it. Let me pop this out. Okay. What am I doing? Okay. Technically the iterator returns option result string, but inside the for loop the option gets unwrapped. Ah, okay, yep. That does make sense, right? So as far as end of file, like there's an extra unwrapping step that we just don't see because of Rust's syntax magic within for loops. If you take one item from an iterator, it will be wrapped in an option since the iterator might be empty or consumed. That's how iterators communicate like doneness back out to the host system. That's cool. That makes sense. Okay. Okay, so we're going to make a program. This is going to be a vec of u8, and this is just going to be a new empty vector. And then we're just going to say reader dot read all. Is that what I said? Read to end. Read to end program. And this is, I guess we want to borrow it mutably. Do we have to do that explicitly? Let's see what it says if we just do this. But I guess we have to write the borrow in ourselves. Cool. Now we need to actually copy this into memory, and I don't know if we have a good way to do this. So let me think. What do we have? What does our API look like? Our memory is just a publicly accessible field right now, so let's have a look at our memory. We have this copy, right, where we can copy from one place in memory to another. We probably want some kind of what do you call it when you put something into memory from a vector? Load from vec, maybe? Is this okay? This is a bad name, but let's go with it for now until something better becomes more apparent. So let's say from now is just going to be a vec u8. We could maybe make this an iter. Let's write a bad version first and then try and improve it. the address is just going to be whatever address we give it, and it's going to either succeed or fail because they're just writes. So for I, B, nice. So now instead of just iterating over the vector, we're going to get the index of each thing as well, because we're going to add that to the address. And we're going to say self write adder plus I, B. Except we're going to say if not. We're gonna commit to this bad API for now. Okay, so let's say now we've made a VM dot memory dot load from vec, and we're just going to load it at address 0. And what happens? What happens if we just run the VM here? Well, oh, okay. There's a magic step that we skipped over here. There's a magic step we skipped over. We need to actually turn it into an iterator. You can just chop that off, and I think Rust works out how to use into iter, but because we're calling enumerate, we have to be explicit. Okay, this is actually good. This is useful. You can do a slice of U8. Rust will convert it. That sounds much more versatile. Let's do that. We'll still call it load from back though, because I'm lazy. Okay. I guess we have to dereference this, which sounds silly. Load from back. Oh, that was a really weird. This is a weird looking compiler error, and it's because there's a comma here instead of a colon, right? When you use the wrong symbols, compilers get very confused, and then I get very confused. Okay, let's as U16. This can fail because it's a really big downcast in size, but that's okay. And now we just need to do all of our missing imports. Env use IO buff reader buff read. What else is there? Path and use. Cool. I typed those out by hand rather than copy and pasting because I'd rather try and drill into my head what I actually need. Okay, that's not buff read, that's just regular read. I said this. I predicted that this would be a problem, and indeed it was. You need a mutable borrow that gets passed into this because that's just what Rust wants. It's just how it is. I have missed a thing. Okay, now it's going to run, and it's going to cry. No? Still not. I have to do this. Yeah, that's a lot better actually. The way I had this before, right? The way I had this function signature when it just said vec u8, like this fully like moves the vec, right? You can't use the vec after you've passed it to this function. It makes way more sense to use a borrow here, an immutable borrow. Cannot borrow as mutable because of course you can't borrow as mutable. I didn't make it mutable. No? Excellent. Excellent. Okay, and now it cries because I didn't give it an input file, but that's good. That's very good. Now this has a result. We're going to say map error. X. And then we're going to just consume that. That's going to hopefully, once we fix our brackets and once, yep. You need a reference tool? Yeah, and it's good that you pushed me in this direction because the reference makes way more sense than the actual move, right? That's just kind of silly. There is a time and a place for an API that would have a move there, but this is not it, in my opinion. Okay, perfect. Now we've got the crash we expect. We're going to say what do I call this? Prog.bin. And that runs. And that is a complete program. So we have a working assembler. Let's commit this while I think of it. Let's go source memory. Do I add these separately? Probably, right? Let's say source memory, load vec, method to load vec to memory. In the VM binary, sorry, these are going to be really granular commits, but we'll just work like this for now. I think it's a little bit clearer for anyone trying to follow this through later, and maybe for me if I try and follow this through later. We'll try and have lots of small commits. Not too small. This is probably too small, but we'll find a happy medium. As we work on bigger things, it'll get harder to do commits this small. VM load program from file. And then we're also going to add cargo.toml and source bin asm. Add we're going to put assembler in quotes. It's not really an assembler. It's a binary thingamabob. Cool. So there's two things that really stand out right now. One is that we have a fixed number of steps, so even if we add more instructions, it's not particularly useful. We need some kind of way of telling the machine to stop. But also, I'm going to come in and I'm going to try and implement daemon's suggestions here and see if I can make this a sick what's it called? Rust vec flatten. Very exciting, very exciting. Cool. So, flatten. Sorry. Flatten. Is this just magic? Is this just gonna work? That sounds okay. That's really cool. That's really cool. So, we're gonna map over these lines. So now instead of this, right? So let's just keep this here for reference. But let's say buff reader new file dot lines dot map. Okay, so now for each line, we're gonna say x dot map no, yeah, we're still gonna have to do this. Right, like we keep this wrapped in a result, maybe. Or when we map, will we not? No, when we map, we'll still get. Wait. We'll map. Yeah, map will still get this in like a result. Now that I've started doing this, Damon, you've lost faith in me. No, I'll work this out. Okay, because this just means that we're gonna have. Oh, we need to so we need to convert at some point from like a vec of result something just into a, well, I mean, let's even go a step further. A result u8 string. And we need to convert that just into a vec of u8, maybe? Or maybe not. Maybe we don't even need to do that, right? Because it's going to be a vec of vec, so we just need to... No. Okay, hold on. So what we're going to have is this, and what we want to turn it into, okay? Here we go. What we want to turn it into is a result of vec u8 string, right? So in other words, this is like having m. This is like, it's like when you have it's like making the inner monad the outer monad, right? That's what we're doing here. This is like the monad swap thing you can do in Haskell. This is the way to think about this, right? I'm not getting rid of the result. I'm just bringing the result to the outside somehow. I don't know how to do it, but we'll work it out. Okay. So then we want to say map. Is it map okay? Rust result map okay. It's just map. It's just map. Okay. So now we have a line. right? So for each line, we say line.split.filter. Is there an empty method? I think there's an empty method. And now we map each thing. Each thing we say U8. Oh no, this is another result. Hold on. Okay, now we're gonna have. Oh no. See, I think this is a bad idea. Again, this was very Haskell-y, and I don't want to get too clever. Okay, clever makes me nervous. Clever coders, you know, they might have like a really sick GitHub, but I'm not sure that it's the path I want to go down. Okay, so map. So this is going to be a vec of result something, right? This is going to be in this case, the something is going to be a vec of result U8 string. So it's a vec of result of result. So again, we just need to flip this around, right? We just need to say vec of result. Okay, hold on. Rust vec of result. What's it called when you bring the inner monad to the outside? Yeah, this thing, literally this. Iterator can be collected. Oh, beautiful. Rust. This is so good. Transpose. I don't know if it's transpose. Is that, what's it called? There's a Haskell. I can probably, hold on. I can probably look it up if I just think of what the Haskell type signature would look like. Is it like M of, well, it's M0 of M1 of A, M1 of M0 of A, right? Can I Haskell? I can Haskell search this. What do they call it in Haskell? Let's go M0 of M1 of A, M1 of M0 of A. No? Anyway, that's not important. I like this name. They should call it this. But it turns out there's just a default, right? So we can just collect this. So radix, not radox. X. Oh, we don't want to overload X any more than... Oh, well, we can. It doesn't matter. Format. Int X. Okay, so... the line has been mapped into a U8. But now we need to say... into iter... We're gonna really push the frickin' the limits of this type system. So let's say let R, and this is gonna be a result vec U8 string equal all this frickin' nonsense, right? Because now we have to do the same thing again. What we have is... Wait, no, but now we just have a result. What do we do with the result? Okay. I'm making an executive decision. This is too clever. This is too tricky. Even if I have a solution, it will be impossible to read and impossible to maintain. Sometimes you just need a for loop. Cool. Okay, so does that still run? Beautiful. Beautiful. Damon, he's on my side. He's come around. He agrees. Lovely. Thank you. Thank you. Okay, so we're loading programs, and we can now write more interesting programs. But how? Well, so do we have? No. Okay, that's good. That's good. How do we actually do something more interesting, right? Because if we look at our VM, we just have a fixed number of steps. So I'm going to introduce a system, and this is going to involve a new operator. Okay, a new type of, oh god, I forgot this rat's nest. Oh, actually, no, there's a to-do in here, right? So let's, I wrote a to-do. I wrote a to-do. It's in, oh no, what have I done? Source VM line 59, okay? I realized, and I think this is something to look out for, right? When you're writing Rust code, if you're working with a result, it looks like this is a bit of a smell, right? Or like working with optionals and then results, this is a bit of a smell. God. And because there's actually a Rusty way of dealing with this, right? So I was reading the Rust docs. I was just having a look at what you can do with these things, and I found this cool function, where is it? Result TE, okay, or. Look at this. Look at what this does. If I can find the actual frickin' FN, okay, or. Okay, I can't find it. I don't know where the function signature actually lives. Apparently not here. Oh my god. Guys, I'm suffering. I'm struggling. This is the opposite. Sorry, it's a method in option. We have okay or. Okay, what okay or does is takes an option and an e, and it gives you back a result te, if which will be okay if the option is some, and an error if the option is none. Right. So it's kind of like turning this into a better type. So what we're going to say instead of this, we're going to say register from U8. If you're confused by that, right, you're going to see why this is really powerful in a second. We're going to say okay or. Instead of doing this match nonsense, okay or format, format and then we're also just going to map it into okay, these are the same thing, right? But one of these we have to do a lot of manual unpacking and wrapping ourselves, and the other one, it just works. It's just magic. I'm going to run this and it's just going to work. I'm not going to have to change anything. Look, ready? Okay, well I made a typo, but other than that, I made a really bad typo. I don't know, I think my brain stopped working there, but now it works. Yeah, okay or's magic, right? Like, look at how much cleaner that is. We don't have to care about how these things are wrapped and unwrapped. We don't have to do that ourselves. This one little function just does the magic for us. When you're working with optionals, when you're working with results, this is gonna save you, right? So this kind of looks the same, but we do work in the middle, so I'm gonna leave it. I think that unpack is more important. Are there any other spots? There really aren't, I don't think. There aren't many other spots. So, okay. Let's just quickly commit that. Cool. Just so that this doesn't end up in another random commit, okay? We're going to get bigger commits as we go. We're going to start doing more things. So I'm going to add an op, and I'm going to call it signal. And this is just going to be, well, it's going to have one argument, right? And this is just going to do a thing, okay? This is going to do a thing. So we're going to define it here. We need to initialize it with a value, which is silly. We're going to write a better version of this. I think I'm just going to put this in the bin and write it the lame looking way, but the dumb way, right? I think it's going to be better. Now, we're going to parse an instruction, but this is going to be the same as when we do it here. So maybe we're going to have to make this some kind of helper function. Actually, let's do that. Let's do that. Let's go parse. Let's say parse instruction arg. This is going to take a instruction, which is an unsigned 16-bit number, and it's going to give us back a U8, and it's always going to succeed. There's no failure model here, right? Because this is just going to be ins and 0xFFOO right shifted by 8 bits, okay? And we're going to give it back as a U8. Then we're not going to have to do this cast. Beautiful. Parse instruction arg milliseconds. Okay, excellent, excellent. And then we just give back op push. Op push. What am I saying? What am I saying? Op push. Sorry, op signal arg. Okay. So what's signal gonna do? Signal is gonna be how we tell the machine we're doing something kind of outside of the machine. Signal. Right. So we're gonna have something that looks like this, and I'm just gonna hack this out right now. This stuff doesn't exist, right? But it's going to kind of be like self.signal handler. So we're going to get something out of a signal handler's map, and then this is an optional, but instead of doing silly unwrapping like we did before, we're going to use okay or, right? So if it's not okay, then we're going to say unknown signal. Right, where signal handlers is then going to just be like hash map function. How do I do a function pointer again? I can never remember in Rust. It's going to be a function that returns a result unit. Actually, maybe it just returns a string straight off, right? Maybe we don't have to do this format. Maybe we just give this back. Maybe. Except we want to put the signal number in there, and that may not be here. Wait, but what if it has its own message? No, hold on. Hold on. I'm mixing up my things. Right? So this is just getting the signal handler, right? This is just getting the signal handler, and that can fail. That can fail with this message unknown signal, and then we call it, and we call it with ourself. We pass the current machine state into it, and I think this is okay. I think passing mute self down like this is okay. So what's this gonna look like? What's this gonna look like? So we need a hash map in our machine now. And what does this take? These are some like signal function, and then it's well, no, sorry, it's going to be a u8 even to a signal function, right? I just got a really good chat message. Compiler about to humble you. I love this. I love this. I love that you're watching out and picking up on this stuff that is about to bite me. I can just imagine you sitting there like really excited. But I'm happy to learn this way, right? This is what I'm doing. And I'm gonna let oh no, I know why this is, I think. We'll see what happens. So how do I make Rust function pointer, right? How do I grab a function pointer? What does it look like? Type signal function is function. We're gonna take a mutable reference to a machine. That's not what I wanted, and we're gonna take nothing else, and we're gonna give back a result. It's going to be unit string. Cool. This is fine, right? This is okay. What happens if I run this? Okay, other than an unmatched delimiter, which is silly. 59. This is fine. This is fine. Here we go. Well, again, other than hash map not being imported. This is fine, right? This is all good. Collections, plural? How do I do this? Here we go. Okay. Expected U8 and not U8, that's okay. U8 and found U8. Get. I guess we can borrow this U8. This stuff seems a little bit odd to me, right? But I guess this function signature is just so that worked. I don't know what's gonna humble me. This is fine. This is fine. Cool. Okay, so that's good. That's good. We're gonna make this a. Where are you? We're gonna make this a pub type so that we can make new signal functions, and we're gonna pub function. What am I calling this? Define handler. And we're just going to say self signal handlers. I think it's put. What am I? I'm missing a thing. This method is not found. Oh, signal handler, signal function. Okay, that is not what it's called. Rust hash map. See, I love this guessing, but how do I insert? That sounds right. There's a bunch of stuff written here. I'm not even going to read it. Let's just find out what happens. Perfect. That's exactly what I wanted. Okay, bin VM. We're going to come up here. We're going to say function. Well, we're also going to now import signal function. Signal halt. I'm calling these signals. You could also call these interrupts, but I'm going to call them signals because I think that's a more fun word. Interrupt makes sense for a few specific things, but it's kind of like, well, what am I interrupting? I guess it's like you're interrupting the normal flow of the VM to call code outside of the VM, but I think signal also makes sense here, right? Like I'm signaling the virtual machine to take an action. I kind of like this. I kind of like this. Machine. Okay, and this also, yeah, has to return a result. Okay, so let's actually even call this a VM. Now, we need some kind of way of saying, hey, we're done, right? So let's even just call this halt. Bool. Right? So we can check this. Let's make it a pub field for now, just because methods are for losers. Cool. And this will tell us to just stop running, right? So now instead of this, we'll say while vm.halt, while not vm.halt, vm.step. Perfect. And now we'll either run forever or die trying. Okay, so excellent. What op is this? 0, 1, 2, 3, 4, 5. So 5. Oh, we need to define it as well. What? And we can really choose here, right? So we can say vm.define define handler. Let's say 0x10. Let's say 0x90. Signal halt. Cool. Does this run still? No. Okay. I'm gonna go to the bathroom, and when I come back, we'll try and fix this fun little compiler bug. Back in a sec. Ooh, that's all of my face. Let's go here. That's a bit nicer, isn't it? It's a bit nicer. Sweet. So, this is really simple actually. I thought I would need to export this type, but I really don't. There's nothing, I really don't. So we can actually, this doesn't need to be pub. Doesn't need to be pub. So now when I do this, I don't get the warning anymore, but I will find option unwrap blows up. And this is gonna be in source VM 127. So somehow a memory read is failing. Oh, and that makes sense actually, right? Doesn't that make a lot of sense? I think so. But let's rather than, so this is an option, right? So let's use our friend OK or format read fail at, right? And now we can get whatever the program, oh well, let's get even better. Let's say program counter read fails at whatever this program counter is, and then unwrap it as an error. Now when we run, we'll find out that we're literally just reading through all of memory, right? This is as high as our memory goes, I guess. And the reason that happens is, well, there's nothing to stop us now. We're just going to keep running until we hit a halt. And 0 is a valid op, right? Because that's just our no operator. If anything, we probably actually should make it like 0 be a crash the machine operator, and 1 be our no op. But anyway, like quietly carrying on when you hit a 0 is maybe not desirable, but that's a later problem to cross. For now, let's just write a better program. Test.asm, okay? So now at the end of our program, we're gonna run a signal operation, which I think is 05, and we said that FO was thing. So let's cargo run bin, where are we? Cargo run bin asm test.asm prog.bin unknown signal FO. Okay, that's fantastic. That's much better than what we had before. What did I define? Obviously, because I didn't define it as F. I'm going to define it as FO. I think that's a better number. And now it runs and halts as we expect. If we jump back in to our test.asm, we can change these numbers around. We can say like FO, and then we'll get a much bigger number. 250. Sweet, that sounds about right. Because it should be 5 less than 10, 11, 12, 13, 14. Yeah, it should be 5 less than 255. That looks correct. So there we go. This has, I'm probably going to have to call it there. This hasn't been the longest stream. This hasn't been the most productive stream, but it has been a lot of fun. We've made some good little improvements, okay? Our machine now, let's bring my full face up. Our machine now, we can write programs for it outside of just poking them into memory, right? We can actually tell the machine to stop and send extra signals through the plumbing of the machine. This is going to be important later on. This is going to let us do a lot of cool things with this machine, right? It's going to let us step out of the machine and making it part of the API, right? Not actually something that is part of the machine, but something that the consumers of this library can define as they see fit. How do you want this machine to stop? It's up to how you define up to how you consume this library. So, for example, well, let's not get ahead of ourselves. There's a lot of fun things we're going to do with this. I'm excited about writing it, and I'm excited to come back and do more. So thank you very much for tuning in. I'm Tom, and I will